Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve rational equations. This is part one of our multi-part series. We're going to be focusing on problems where the denominator components are monomials. Alright, let's consider the following problem. We are to solve and of course check, because they could be the introduction of extraneous solutions in the solution set, so it's imperative that we check. So the problem is x plus 2 divided by 2x plus 1 over x squared equals 5 over x squared. Okay, before we get started, let's go ahead and write down the steps that will guide our problem solving process, okay? Alright, so first thing you want to do when solving rational equations is you want to make the denominators the same. Alright, so make all the denominators the same. Okay, all we're just doing is converting all these rational expressions, these algebraic fractions, into equivalent fractions that have identical denominators. And what is that called? You're basically converting all of them to equivalent fractions where their denominators are equal to the lowest common denominator. Okay, so that's a target expression that you want all the denominators to attain. After doing that, you're going to proceed to eliminate all the denominators, eliminate all the denominators. How do you do that? By multiplying the entire equation by the LCD. Alright, so that's why we executed step 1 in the first place, was to put the equation in a position where the entire denominator expressions are eliminated by simply multiplying by the LCD, because they all have identical values as the LCD. Okay? Now when the denominators are eliminated, you just simply solve the resulting equation. Okay? So let's go ahead and do that. Now, first things first, let's go ahead and make all the denominators of these three terms equal to the LCD. So what is the LCD of 2x, x squared, and x squared? To do that, we're just going to decompose the denominators and then multiply by factors that are missing in any of the components. Alright, so we have x plus 2 here. That one is prime, so we're just going to place it in the parentheses. We have x plus 2. Now the denominator is 2x. We can decompose that into 2 times x plus, here we have 1, which is prime, divided by, decompose the denominator, x times x, equals 5, which is prime, divided by the denominator, x times x. Okay, the decomposition of x squared is x times x. Now let's inspect all the denominators. What you notice is that the denominators are not identical. This has a 2 in it, the other ones do not have a 2, so to fix that discrepancy, we're going to proceed to multiply these two terms by 2, not just in the denominator, but in the denominator and numerator. Okay? We know that 1 is the multiplicative identity. If you multiply by 1, you will end up with the same expression that you started with. So what we're doing is just multiplying by 1, which is the same thing as 2 over 2. Alright? Now take a look at all the denominators. Are they all the same now? The answer is no. They have a 2, but these two terms have 2 x's. This has only 1. So to fix that problem, we're going to multiply this term by x in the numerator and the denominator. Okay? Now let's combine everything back together. On the left fraction, we're going to distribute x into x plus 2. So that yields x squared plus 2x divided by 2x squared plus 2 divided by 2x squared equals 10 divided by 2x squared. So ladies and gentlemen, we have found the LCD. Okay, so based on the work we just did, we can see that the LCD of the denominator terms of the original problem, which are 2x, x squared, and x squared, the LCD of these three terms is equal to 2x squared. Okay? Alright, we're done carrying out step number 1. Now we're going to move on to step 2, which is the elimination of the denominator by multiplying by the LCD. So what we're going to do is multiply the entire equation by the LCD 2x squared. Now what happens is that this 2x squared is distributed to all the three terms. Okay? When you distribute it, what happens is that 2x squared is going to cancel out the denominators. Let me show you what I'm talking about. So we have x squared plus 2x. That divided by 2x squared will be multiplied by that 2x squared we introduced plus 2 over 2x squared. That will also be multiplied by the 2x squared. Now since we're multiplying both sides of the equation by 2x squared, we're not changing the problem. Okay, 2x squared we are multiplying by 2x squared also. So what happens? The denominators divide out. So this divides out with that, this divides out with that, and this divides out with that. Okay, so the resulting equation is the following quadratic: x squared plus 2x plus 2 equals 10. Okay, so we've changed this complicated rational equation into a more manageable quadratic equation. Okay, now to solve a quadratic, we're going to go ahead and put it in standard form first. So we're going to subtract 10 from both sides, and then we will have x squared plus 2x minus 8 equals 0. Now we have a quadratic trinomial. We're going to factor this using the x game or the AC method. So AC in this case is negative 8 and B is 2. Now what two numbers multiply to give you negative 8 and add to give you 2? The two numbers are negative 2 and 4. Okay, so in this situation, our leading coefficient A is equal to 1, so there is no need to factor by grouping. Okay, we can just skip this grouping component and just jump right to the factored state. X minus 2 times x plus 4 equals 0. Now using the zero product property, we're going to set both factors equal to 0, and then we're going to solve. Okay, so in the first case you add 2 to both sides, that yields x equals 2, and then in the second case you're going to subtract 4 from both sides, and that gives you x equals negative 4. Okay, now these are our potential solutions. We do not know if they are the actual solutions yet. How do we determine if they're solutions or not? What we're going to do is we're going to simply do a check. Okay, we'll check by substituting these answers into the original problem. Alright, let's go ahead and do our check. So let's see. Now what we're going to do is we're going to substitute the answers into the original problem and see if we arrive at a true statement or not. Okay, so the original problem is x plus 2 over 2x plus 1 over x squared equals 5 over x squared. Okay, let's go ahead and divide our workspace so don't get it confused. Now, the first thing we're going to do is we're going to check to see if x equals 2 is in fact an answer to this problem. Okay, so let's start off by checking. We're going to check x equals 2. So to do that, we are simply going to plug in this answer into this equation and see if we end up with a true statement. Alright, so let's do it. Alright, so if we replace x's with 2, we'll have 2 plus 2 over 2x. Instead of 2x is going to be 2 plus 2 plus 1 over 2 squared. The question now is this equal to 5 over 2 squared? Okay, so all we'll do is we'll simplify the left side and the right side and see if we arrive at an equality. Following the order of operations, we'll simplify the left side and right side simultaneously. So here we have in the numerator, since it's separated from the denominator, we can go ahead and add that. 4 over 2 times 2 is 4, plus 1 over 2 squared is 4. Now, is this equal to 5 over 2 squared, which is 4? Is it? And then you can just add these two up, since the denominators are already the same. Is 5 over 4, is it equal to 5 over 4? The answer is yes. So since we have a true statement, we know for sure that x equals 2 is not just a potential solution, it's an actual solution to the problem. Alright, so now we're going to go ahead and do our check for the second potential solution, which is going to be x equals -4. So we are now going to check x equals -4 and see if we end up with a true statement also. Okay. Alright, so what we're going to do now is just simply substitute the answer into the original question. So the question is -4 plus 2 over 2 times -4. So I'm just plugging in this answer into this original equation, plus 1 over -4 square. Is it equal to 5 over -4 square? That's the question. Okay. Alright, so using order of operations again, we're going to simplify this completely and see what we get. So we're going to have -4 plus 2. Since you're adding numbers with different signs, you subtract and keep the sign of the bigger. So you have -2 over 2 times -4 is -8, plus 1 over -4 squared. If you raise a negative number to an even power, the negativity goes away, so you have positive 16. Now, is this equal to 5 over 16? Is it? Well, let's keep on working and see what happens. If you divide two negatives, negative divided by negative is positive, so this becomes a plus. So is 2 over 8 plus 1 over 16, is it equal to 5 over 16? Is it? If you can basically combine both of them, since well, we can't combine it. The denominators are different, so we have to find the LCD. So what we'll do here is multiply by 2 top and bottom. Okay, and what does that yield? We have 2 times 2, which is 4. Is 4 over 16 plus 1 over 16, is it equal to 5 over 16? That's the question. Well, we can clearly see what the answer is, right? You just simply add these two, since the denominators are the same, is 5 over 16. Is it equal to 5 over 16? It certainly is. So that shows that both answers are actual solutions to the rational equation. We do not have any extraneous answers here. Now let's assume that one of them failed the test and we did our compute verification steps correctly. All we'll do here is just simply eliminate whichever one fails the test, and we'll take the other one, whichever one passes the test, as the solution to the rational equation. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of rational expressions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any algebra concepts in general, just place your question in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. We upload videos to our YouTube page on a regular basis, so if you would like notifications of our uploads, just simply subscribe. Don't forget to visit our website mathgotserved.com for access to a wide variety of tools to aid you in mastering mathematics. Thanks again for watching and have a wonderful day. Goodbye.